Imagine two appliances. 1000-watt electric iron runs for 10 minutes and a 100-watt LED bulb runs for 10 hours. Which one uses more electricity? Many people think the iron does. That is this one, 1000 watts, because it has much higher power rating. But is that really true? To answer this question, we need to understand electrical energy. Okay? By the end of this video, you will know the difference between power and energy, how electricity bills are calculated, and what a kilowatt hour really means. Let's begin. Before talking about electrical energy, let's understand energy itself. Energy is the ability to do work. Everything that happens around us requires energy. A moving car needs energy. A fan needs energy to rotate. Without energy, no electrical device can operate. What is electrical energy? When electricity flows through a device, electrical energy is converted to another form. For example, a bulb converts electrical energy to light and heat. A fan converts electrical energy to mechanical energy, right? So the total amount of electrical work done is called the electrical energy. That is, it is the total amount of electrical work done. Okay, see, you have to understand the difference between power versus energy. See, you need to know the difference. Power tells us how fast, duration, how fast energy is used. Energy tells us how much energy, how much has been used. Okay, see, think of a tap filling a bucket. Okay, the flow rate of water is the power, and the total water collected in the bucket is the energy. Okay, so the faster flow fills the bucket more quickly, but the amount collected depends on flow rate and time. Okay, so electrical energy equals to power into time. This is an important formula. P is the power, T is the time. So this simple equation explains why time an appliance runs is just as important as its power rating. Okay. Now, what is the SI unit of energy? SI unit of SI unit is joule. But for homes and business, joule is very small, right? So what they use kilowatt hour. 1 kilowatt hour means 1 kilowatt hour equals to 1000 watt of power for 1 hour. That is kilowatt hour. So it is a unit of energy, not power. Okay? So when your electricity bill says you have used 250 kilowatt hour, it means that your home consumed a total of 250 kilowatt hours of electrical energy during the billing period. The bill is based on how much energy is used. Okay, not simply the power rating. Okay, and there's a misconception. Many people say my fan is only 770 watt, so it won't affect my electricity bill. But if that fan runs for many hours, if it runs for many hours every day, it can use so much amount of energy, large amount of large amount of energy. Okay, it's not that it's just 70 watt fan uses so electricity will be less. No, it is depends on how much of energy is used. So both power and time determine the energy consumption. Okay, so now we know what electricity is, what is voltage, what is current, what is resistance, power and energy. Right, now we will explore what are conductors, insulators and semiconductors and understand why some materials carry electricity easily while others don't. Imagine touching a copper wire and a plastic ruler. One can carry electricity easily, the other almost completely blocks it. But why? Because the copper is used for electrical wiring and plastic is used for insulation. Right? Okay. But why is copper used for electrical wire and plastic is used in insulation? Why? Because the answer lies in three types of material. First is conductor, second is insulator, third is semiconductors. Conductor is the material that allows electric current to flow easily. See, because conductors it has lot of free electrons that can move when the electric field is applied. Okay, now since it's like you have to understand this concept, I will teach in upcoming chapters, but you have to remember, if electrons move, it has a drift velocity. If it has slow drift velocity, how come the bulb glows very fast? It is because of electric field. This I will teach this concept in the next video, but okay, remember it's the electric field. Okay, now since the electrons can move easily in a conductor, conductors have low resistance. Examples: copper, silver, gold, aluminium. See, copper is widely used in electrical wiring because it conducts electricity well and it's also affordable. Okay. Next, insulator. It is a material that strongly opposes the flow of electric current. See, its electrons are tightly bound. So there's very less free electrons. Okay, so it can't move easily. Almost no current flows. Example: plastic, rubber, glass, wood. That's why the electrical wires are covered with plastic to protect us from the electric shock. Next is semiconductors. It is the material whose conductivity lies between conductor and insulator. It does not conduct electricity as well as copper, but it does not block it as completely as plastic. Okay, the most common example is the silicon. See, by adding small amount of impurities, that is known as doping process, the conductivity can be controlled. So that's why the semiconductors are used to make electronic devices like smartphones, computers, LEDs and microchips. That's why we use semiconductors. Okay, so we will do a quick comparison. Conductors have low resistance, many free electrons, current flows easily. Insulator, high resistance, very few electrons, current hardly flows. Semiconductors. Semiconductors, moderate conductivity can be controlled used in electronic devices. So let's revise. We know conductor allows current to flow easily. Insulators prevent current from flowing. Semiconductors have properties in between and are the foundation of modern electronics. So in the next video, we will learn about circuit elements and understand how a battery, resistor, switch and load work together to form an electrical circuit. Thanks for watching. So these topics are the most important topics, okay, till electrical energy plus this conductor, semiconductor, insulator, very important topic. So this is the basics of electrical engineering. So in next video we will learn about circuit elements, which is very important, basic and the foundation. Okay, thank you. Thanks for watching.